simple. You just have to make sure that you're following the rules right when you're doing that the focus is closer or farther away or equal to or whatever.
Yep.
That's funny.
Question. It does. Yes.
So, are those two arrow lines, they're supposed to look different?
This is supposed to be a different distance than this.
No, I'm saying, are they...
Like the way I dot them?
No, the lines themselves, not the dots.
No, they're not supposed to look different. These should be symmetrical. That's me being sloppy. I apologize.
Why are there extra dots?
Because we have the origin, which is the pole, which is one of the focal points.
Well, yeah, but that's the only thing that matters, I thought.
Well, then I wanted to do a point on each side of the...
Oh, but, like, there's not actually, like, a real, like...
No, this is one D on the directrix, and this is another D on the directrix.
But it doesn't, like, actually matter.
Sort of does. And eccentricity, this concept of eccentricity helps describe curvature. Things with a small eccentricity will curve back on themselves. Things with a big eccentricity will fly away from each of themselves.
Well, like
things with a one eccentricity are a parabola.
You can use any point on the directrix, right?
Yes, and this has and any point on the no, you couldn't. Let me rephrase that. You could use any point on the curve, and the distance from that point on the curve to the directrix is defined as the distance.
That's what I meant.
That's perpendicular.
That's what I meant.
Yeah, okay, good. But I meant to say that, so I apologize for that. That's a good point. You always define the distance to the directrix as the shortest distance, which is always the perpendicular distance.
Straight line.
Okay?
You're making me turn.
Now, you'll be shocked to hear that these also have polar equations.
Oh, I was not expecting that.
Good night.
And they'll always take a certain form.
You know my bag is breaking.
Oh,
that's
so sad.
totally irrelevant.
I know.
You're irrelevant.
Your mom is irrelevant.
Okay, stop.
You're
No.
very clever.
Alright, this works.
I really wish I could be in your head sometimes.
I really wish I could not be here. No offense.
Okay.
Me?
Now.
Me.
Me?
Okay. Let me see if I can do this in... If I can do this clearly, that'll be the big thing. Got to erase this part. Sorry, Connor.
Well, if it's not clear to you, then it's not.
Yeah, erase that left part. You can do that.
Okay, I'll try. Okay.
So you better.
General polar form. Okay. Every conic that goes left or right. Every conic that goes left or right, by which I mean a ellipse with a horizontal semi-major, horizontal major axis. A hyperbola where the wings go left and right. A parabola that goes left and right.
So the ones that we graphed.
Yeah, all the ones that we graphed are of the form r equals EP over 1 plus or minus, wait, that left out an E, don't write that down yet, E cosine theta.
What is E? Oh.
Eccentricity.
I knew that.
Okay. And P is...
Point.
Well, P is what it's been all this time. The directrix, well, it's a little different. P is distance from...
Is that an ellipse or a circle? What is that thing? The big
Which
the
one?
directrix
on the right.
That's an ellipse.
Is that an ellipse? Okay.
Yep. To the focus. P is the distance from the directrix to the focus. That's a little bit different than how P was used before.
Totally.
Because P in the parabola, remember, was
Wait.
just half the distance from the directrix to the focus. It was the difference, the distance from the vertex to the focus and the vertex to the directrix. Yes?
It says plus or minus E cosine, right? Does that mean we have to split it off like with the quadratic formula, or?
No, it's a little bit counterintuitive, though.
What do you mean?
So then we'd have two answers.
Well, no, plus opens left.
Oh,
Minus-
so it's like two different. It's not okay. Just
Yeah,
kidding.
opens right on a parabola.
So this is only for parabola.
No, it's because if the eccentricity is more than 1 or is 1, it's a parabola. If it's less than 1, it's ellipse. If it's greater than 1, it's a
Are
it's
you sure
a
plus is
hyperbola.
open right?
Yeah, it does. Yes, sir.
What? Plus
It's
opens
counterintuitive.
left.
What's the difference between an ellipse and a hyperbola? So, yeah.
Like everything else in math.
But the way he said
Okay.
it was that the plus opens right.
Well, on a parabola, this is true. Now, on an ellipse, okay, this is the
So
Just talk about
negative
it.
opens-
yeah, this works. On the ellipse, the plus is
I have a bruise on my arm.
okay. The second focus is further left.
I thought there was only one focus or anyway.
Minus the second. This other focus is still there. You don't have to care about it. I'm just trying to give you a way to know which way it goes.
Okay.
And these are on an ellipse. Okay? Now, so what that means, this ellipse here is must be a 1 minus cosine theta. If it were a 1 plus cosine theta, this other focus would be over here, and the directrix would be over here.
Oh, so it's flop.
Yeah.
Okay.
If the minus.
Wait,
What do you
I'm
think happens if
confused.
this? What do you think happens if this is sine?
Up and
Up and down.
Everything goes up and down instead. The parabola either opens up or down, or that's the opposite of what you'd think. The minus gives you the smiling parabola. The plus gives you the frowning parabola.
That's obnoxious.
hyperbola.
Hyperbola. Okay, this is a
Pause.
Call it hyperbola.
yes.
Are you normal?
What are you talking about with the second focus?
It is a
Okay.
Hyperbola.
This must be a case of 1 minus e cosine theta on the bottom, because there's always another focus somewhere over here, right?
A little further right.
And it's further to the right if you have a minus sign here. It's further up if you have 1 minus e sine theta. So the cosine will get you all the horizontal ones. The sine will get you all the positive ones. The plus or minus will counterintuitively tell you whether they open up or have the bulk of their second focus up or down, or left or right. Yes?
Okay, the one on the other bowl right there. That's the hyper.
This is the hyperbola.
Yeah. Will they ever go up and down, or are they always up
Yes. When the sine, anytime you see the sine theta, it'll be up or down.
and down? Okay.
So, but to get the plus or minus straight, on the hyperbola, plus or minus, if you have plus in there, then the other wing is left. And if you have a minus in there, the one that's not wrapped around the origin, the other wing is right.
So the one on the origin is just gonna be this. Is it gonna be the same every time?
There will always be one focus on the origin. So if that's a parabola, that's your only focus.
You know what I'm saying? Like for this one.
For this one?
You know how like it's right there. Is it
Yeah.
always gonna be there?
Yes, one of them will always be here.
Or would it be split depending on the other one?
If I make it, this one must be a
Minus.
minus. Other wing is on the left. This one must be a plus. Okay, so if I make it
Oh.
minus, then I'd have a wing here and the other
then
one over here.
So it's just basically all.
Yeah, it's all flopped. Yeah, and that's what plus or minus does. If I make it sine, they'll all go up or down.
Right.
Okay. Now what you'll get.
Hold on. Does that mean that these wings would go like that instead of like sideways, or would it still be sideways?
It'll still be sideways unless it switches to sine.
Okay.
If it's that part's kind of intuitive because we've always talked about how cosine lines up with x and sine lines up with y. So that's intuitive here. All the cosines give us horizontal things. All the sines give us vertical things. What's kind of counterintuitive to me anyway is how the pluses or minus works. Because if you get a minus on a parabola,
So
then
this is cosine.
yeah, that must be cosine and it must be plus.
Okay.
This is some number over 1 plus something cosine.
And what is the not the bottom part? What is the denominator?
The numerator, the EP?
Yeah. What does that do?
E is the eccentricity, P is the distance from the directrix to the focus.
Right, but if
Okay, I'm going to give you a couple examples, and then we're going to Blue's Clues our way through what they must mean.
Are we given the directrix or the distance?
Yes, you will be, and I'll show you how. Okay, I'm going to start erasing this part now. Okay, let me pick one kind of at random.
Alright.
Now, here's the deal. These rules only work if it's